is to solutions for Math 111. We're asked to simplify this big mess right here. And the way you want to do this, you kind of think about it like it's a fraction. If you're adding fractions together, you'd have to get a common denominator. One way to get a common denominator would just be to cross multiply. But you'd end up with the big mess, and I don't think you'll be able to simplify as far as you'll be able to as if you would factor out both of the bottoms here. So if we do that, in this first rational expression, the leading coefficient is 1 down here in the polynomial in the denominator. So we need two numbers that multiply to be 2, positive 2, and add to negative 3. You mess with that for a while, I think you'll come up with x minus 1 and x minus 2. Seeing over here, again, we have the leading coefficient is a 1, which is kind of nice. So we need two numbers that multiply to positive 8, add to negative 6. Let's see, x minus 2 and x minus 4 will do the trick. And now when you have it written like this, it's easier to see that we can get the least common denominator will be x minus 1 times x minus 2 times x minus 4. So what we got to do is multiply this guy over here by x minus 4 over x minus 4. Really, we're just multiplying this guy by 1. Although now it looks like the equal sign's in the wrong spot. So I color this in and kind of hide that and put the equals over here. Anyways, we just multiplied this guy by 1, so we haven't changed anything. And over here we'll multiply by 1, but the form of 1 we want is x minus 1 over x minus 1. And the reason why is now the denominator here is the same as the denominator here. So if we maybe I'll distribute the top out. X times x minus 4 is x squared minus 4x. And then the denominator is x minus 4, x minus 1, x minus 2. Let's see, over here we have 4 times x plus 1. So that's 4x minus 4. And the same denominator, so we only have to write the denominator once, kind of merge the terms up top, and we get to here. And then up top we can combine like terms, negative 4x and plus 4x just cancel out. So we got x squared minus 4 divided by x minus 4, x minus 1, and x minus 2. We're still not done because x squared minus 4 can be factored to difference of squares. So it's x minus 2 times x plus 2, 2 being the square root of 4, divided by this same mess. But what you get to see now is that we have an x minus 2 in the numerator here and an x minus 2 in the denominator. So those guys cancel out, and we get our final answer is x plus 2 divided by x minus 4 times x minus 1. Put a box around it because it's the final answer. Alright, moving on to number 2. In the second problem, we have to find all solutions to this equation, but you got to make sure you complete the square. We're going to do this problem in class, so I will do it the way that I do it in class. To be honest, there's a way that's probably a little bit easier, but the problem with doing it that way is that way won't work later on, in this quarter actually, pretty soon in a couple of weeks. So I want to do it a way now, even though it might be a little bit more difficult, so that it works better for us later on. So my method that will continue to work for us is step 1. All you got to do is put brackets around all the terms that have an x in them. Right, so we still got this plus 1 out here. I haven't really done anything at all. I added these brackets, but really the brackets aren't doing anything. But what you complete the square on are only terms that have x's in them. But the other thing you need to complete the square is a leading coefficient of 1, which we don't have here. So what we'll do is we'll factor out a 3 from everything inside those brackets. A little bit tricky to factor out a 3 from a 5, but it ends up with 5/3. If you have trouble seeing that, distribute this 3 back in, and you'll get back up here. Okay, so now what we have is a form we can complete the square on. Everything that's out of those brackets will leave out of those brackets. but these things in the brackets here, we will complete the square on. And what you do is you write x plus half of this number here, half of 5/3 is 5/6, and square that. The problem is what's in these brackets right here is not the same as what's in these brackets right here. If you had FOILed this out, you'd get x squared plus 5/3 x, but you'd also get plus 25/36, which is 5/6 squared. So what we want to do is subtract 25/36 down here so that these brackets are the exact same as these brackets up here. And so now they are. So we're in good shape. We're kind of done completing the square. See, the first thing we want to do is take care of this 3 out here. If you distribute that back into the brackets, you'll get 3 times x plus 5/6 squared minus, see, 3 times 25/36, you could call that 75/36, or to keep the numbers a little bit smaller, call that 25/12. The reason why is 36 is 3 times 12, and the 3 and this 3 cancel out. Something else to be careful of here is you take this 3 and distribute it into the parentheses, or into the brackets, but you can't distribute into these parentheses because these parentheses are squared. The 3 is not. So all that, and then plus 1 out here. Maybe instead of 1, I'll write 12/12 equals 0. And negative 25/12 plus 12/12 is negative 13/12. So you get 3 times x plus 5/6 squared minus 13/12 equals 0. Now finally we're in a form where we can solve for x. See, the first step would be to add 13/12 to both sides. Next step, divide both sides by 3. See, if you divide by 3 here, you get x plus 5/6 squared. Divide this side by 3. Maybe it's easier to think about it as multiplying by 1/3. You get 13/36. Now take the square root of both sides. You get x plus 5/6 equals, make sure you put in the plus or minus anytime you take a square root. So finally, x equals negative 5/6 plus or minus the square root of 13/36. But as you remember from last section, you don't want to leave a square root in the denominator. But what's kind of nice here is we don't even have to rationalize, because 36 is already a perfect square. It's equal to 6. So final answer could be this guy right here, or if you want to put it all over one denominator, that's fine too. To end up with something like that. And that is the end of the second quiz.